Good day everyone. You are watching Dreams YouTube channel of Pililla Integrated National High School. I am Mrs. LORNZ, your math teacher today. We are now on quarter 2, weeks 6 to 7 in Mathematics 8. Weeks is all about the biconditionals, inverse, converse, and contrapositive statements. If you will listen to me attentively, then you will completely understand our lesson today. What I am saying about? Again, I repeat, if you will listen to me attentively, you will completely understand our lesson today. What I am talking about? I'm talking about a conditional and its respective outcomes. This is an example of a conditional statement or if-then statement. For today's lesson, you will learn how to determine the relationship between the hypothesis and the conclusion of an if-then statement. You will learn also to transform a statement into an equivalent if-then statement and determines the inverse, converse, and contrapositive of an if-then statement. To start with, let us have a recall of your past lesson. You are asked to identify the conclusion and hypothesis for this conditional statement. If you will listen to me attentively, then you will completely understand our lesson today. Now, can you give me the hypothesis? Very good. The hypothesis is you will listen to me attentively. How about the conclusion? Yes, the conclusion is you will completely understand our lesson today. You know, class, that you need to remember that conditional statements are true if the hypothesis and conclusion are both true. And what if we interchange the conclusion and the hypothesis? Will the resulting condition be true? I repeat my question. The question is, if we interchange the conclusion and the hypothesis, will the resulting condition be true or the conditional statement be true? In this lesson, you will be able to make a converse statement from the given conditional statement. The same way, an inverse and a contrapositive statement can be derived from the conditional statement. Let's take this example. You have to do the following. Determine if the given statement is true. Switch the hypothesis and the condition to determine if the resulting statement is true. Write the hypothesis and the conclusion in negative form. Let us take our first problem. Our first problem is, if the triangle is equilateral, then it is equiangular. Now, for our statement or original statement, and we may say that this is the conditional statement. If the triangle is equilateral, then it is equiangular. Therefore, our given is already in conditional statement. Now, for the inverse, if the triangle is not equilateral, then it is not equiangular. Notice, class, that I highlighted the word not, meaning that not is called a negation or a negation word. So therefore, when we say inverse, we use a negation word like not, do not, aren't, isn't, and the likes. Now, let us have a converse statement. A converse statement is if the triangle is equiangular, then it is equilateral. What have you noticed? So you can see here that we switch the hypothesis and conclusion. Now, for the contrapositive, if the triangle is not equiangular, then it is not equilateral. So notice again that I use a negation word, which is not. Therefore, we may say that when we say inverse, it is a negative version of conditional statement, while the contrapositive is the negative version of a converse statement. And therefore, in this case, we may say that the original statement and converse statement are both true. Now, to continue, we can say again that the original or conditional statement is true and converse statement is true. Thus, we may have our biconditional statement. And our biconditional statement is a triangle is equilateral if and only if it is equiangular. Notice the word if and only if. When we use this word, we are now in biconditional statement. Again, our biconditional statement is a triangle is equilateral if and only if it is equiangular. Now, remember class that the words if and only if implies that both conditional and converse statement are true. Given a conditional statement, you can split it into conditional statement and its converse. For our second problem, the given is already in biconditional statement. Two angles are complementary if and only if the sum of their measures is 90 degrees. And our conditional statement is if two angles are complementary, then the sum of their measures is 90 degrees. Now, the converse statement is, if the sum of the measures of two angles is 90 degrees, then they are complementary. Notice, class, that we have both the conditional and converse statement are true. Moving on to our third example, let us have this one. For our original or conditional statement, if angle A and angle B are vertical angles, then they are congruent. Now, for our inverse, if angle A and angle B are not vertical angles, then they are not congruent. Notice, for the inverse, we use the original or conditional statement, but we use the word not. Now, for our converse, we are going to switch the original statement, switch the hypothesis and the conclusion. Thus, we have if angle A and angle B are congruent, then they are vertical angles. Now, for our contrapositive, we will use this converse statement, but we are going to use a negation word, which is not. If angle A and angle B are not congruent, then they are not vertical angles. Notice that both the inverse, the converse are false, and both the original and the contrapositive are both true. So in this case, since we have false, false in our truth table, we have true statement, but true, true or true, we have or also a true statement. In this case, class, you can form a biconditional statement. Now, what is the biconditional statement of this? Okay, what is the conditional statement? If angle A and angle B are vertical angles, then they are congruent. That is our original statement. So therefore, angle A and angle B are vertical angles if and only if they are congruent. To understand better the lesson, let me give you these guide questions and kindly answer me these questions. What are the parts of conditional statements? Alright, yes. The conditional statement has two parts. The if, which is the hypothesis, and the then, which is the conclusion. And the next question is, how do you write a conditional statements? Yes, when we say or in writing a conditional statement is a statement that cannot be written in the form if P then Q, or that can be written, in the form if P then Q, where P and Q are sentences. For this conditional statement, P is called the hypothesis and Q is called the conclusion. Intuitively, if P then Q means that Q must be true when P is true. And where can you write a conditional statements into biconditional statements? Now, if we remove the if-then part of a true conditional statement, combine the hypothesis and conclusion, and tuck in a phrase if and only if, we can create biconditional statements. Moving further, so the next question is, how do you write an inverse statement? First, an inverse statement can be formed by negating the hypothesis and conclusion of the statement. And if you negate the converse statements, what do you call the resulting statements? The answer, when you negate the converse statement, you will form a contrapositive statement. Now, let us try some examples. So, you are asked to write the inverse, converse, and contrapositive of each conditional statement. Now, our given is, if a quadrilateral is a rectangle, then it has 4 right angles. Okay, you have to find the inverse, the converse, and the contrapositive of this conditional statement. Okay, so let us check your board. Okay, please see to it that you were able to get the correct answer. So for our inverse, if a quadrilateral is not a rectangle, then it has no 4 right angles. Now, for the converse, if a quadrilateral has 4 right angles, then it is a rectangle. And for the contrapositive, if a quadrilateral has no 4 right angles, then it is not a rectangle. Moving on to our second example. So again, you are asked to write the inverse, converse, and contrapositive of each conditional statements. Now, our original or conditional statement is, if 2 line segments are equal in length, then they are congruent. Okay? Will you please try to answer this problem? Now, let us check your answer. Now, again, I repeat, our original or conditional statement is, if 2 line segments are equal in length, then they are congruent. Now, our inverse is, if two line segments are not equal in length, then they are not congruent. For our converse, if two line segments are congruent, then the lengths are equal. For our contrapositive, if two line segments are not congruent, then the lengths are not equal. Okay, I hope you get it. Okay. So, any question, class? I hope you understand our lesson today. In this video, I would like to take the following: Practical Mathematics by Evelyn Sara, pages 310 to 315. Pivot 4A Learner's Material, Quarter 2 Mathematics, pages 21 to 25. And the Google and slides go. Before I end up our lesson today, this is your takeaways. Let me give the quotations from Kelly L. Moore. I don't want someone to believe my lies. I need someone to accept my truths. Thank you very much for listening. Keep safe, everyone.